Hi guys, how are you? My name is Yi Zhang. Today I will introduce to you the basic steps using the Ansys Icepak for the thermal and the velocity simulation. And today we will build a model like this. There is the enclosure, and inside of the enclosure there are heatsink and three fans. So we can simulate the thermal distribution and the velocity of the air and the pressure of the air. And if you don't have any background of the Ansys Icepak, and don't worry, and this is designed for a beginner, and so just follow me, and you can learn how to build a block or how to simulate it with the Ansys Icepak. So let's begin. For the first, we just open a new project, and we can create a lane. For example, we can create the thing name 1 because I have built a model in my computer, and you just I want to show you how to build it, so we do it again, and we create. Okay, so in the beginning, and we can find there is the big square. Actually, it's a block. This block is in the cabinet with the dimensions 1 meter times 1 meter times 1 meter. It's a default setup. So in the first stage, we want to change the dimension of the cabinet and make it more suitable for our model. And okay, so we can find in the left of the window, and there is some there is the cabinet. This is the manager window, and we can double click it, and we also can choose the cabinet, and we click the edit object. It's the same. So, but I prefer to double click it. It's simple. And in the setup of the cabinet, and we can change the name, and we also can change the geometry. So we change the geometry for the x-axis 0, and the x ends on the 0.075, and the y-axis also 0, and but ye is the 0.25, and the z-axis is the 0, but the ze is the 0.356, and we can update, so we can find the cabinet is much smaller, and we can choose done. And you can click the scale to fit, and to make it to scale the view of to fit your graph window, and that is much convenient for you. And then we want to create a backing plane, so we choose this, the red one, create the blocks, and we can find that there is the tiny blocks inside in the center of the window, and we double click it, and we can change the geometry information. In the geometry information, x starts to the 0, and ends at the 0.006, and y-x starts to 0, and ends at the 0.25, and the z is 0, and this is the 0.356. Okay, we can click done. We can find the blocks becomes looks like a plant. And in this cabinet, or in this enclosure, we will build up some fence in this side. So we have to change the opposite side is open, and to make some airs and the input or the output. So we have to set up some opening So we choose this one, create the openings, and then we click it, and we can find it. There is the small square inside in the center of the graph. And we also double click it, and we change the geometry information, and the x stars and the 0.006 and ends and 0.075, the y-axis 0 and 0.25, and the z-axis 0.356, and we can click it down, and we can find it now in the side of in this side, and it's an opening, and the air can come in or get out. It's totally free. Okay, so in the opposite of the opening and in the side, we will build the 3 fans. So for the first, we build up the first fan, and we can choose the create fans in the Ansys Icepak. Is very easy for us. So we just click it, and we can find it in the mode manager window. There is the fan in the central, and there is the tidy fan. And we can double click it, and we can change the geometry. And for the fan, we want the model as the 2D, and we want the circle line. We can find it in the XY plane, so the plane is XY. So and the central is the 0.04, and the Y say 0.0475, and Z say 0. And for the radian, and the outside radian is 0.03, and the initial radian is 0.01. And we also go to the property, and we can set up the fan type is intake or the exhaust, but for this case, and we choose the intake, and we also can choose the flow direction, and we also can choose the fan flow under the fan flow tab, and we choose the flow type is the fixed, and also the volume is the 18, but we change the parameter, change the unit is the CFN, and then we can choose the update, and we can find that there is the fan on the side that we can click down. Because we want 3 fans, so now we can use the copy and paste. It's much more efficient, and so we can you can right click your mouse and choose the copy. We want 2 more fans, and we choose the operations is translate, and we want 2 fans and in the y direction, so we choose the y offset is 0.0775, and we click apply, and we can find that there are 2 more fans in the side. Okay, now we have finished the enclosure setup. We have finished the opening, and we have set up. We have built a plane, and we have built 3 fans. And now we want to say some thermal sources. So we choose the create source, and we can find in the central there is a small source, but we have to make the dimension is right. So we also double click the source, and we go to the geometry, and we can change the information of the geometry. First we change the plane is the YZ. Sorry, it's in the YZ plane. Yes. And the x stars and the 0, and there is 0.0315, and the y ends at 0.0385, and the z is starts at 0.1805, and the z is 0.2005. And in the property tab, and we can set up the thermal specification, and we can choose the total power losses at 33 watts, and then we can click update, and we can find the sources is just on the surface of the plane, and we can click down. And then we also use the copy and paste and to build more sources. So we can click the copy, and we choose the 4 copies, and the translate, and in the y offset is the 0.045, and we can click apply, and now we have 1, 2, 3, 4, 5. We have 5 sources in the direction. And then we will build some heatsink, and in these cases this is the one of the method to build the heatsink, and we create the things of the heatsink, and to copy and to get more things. And in the next video, or in other video, I will introduce the other methods, and so you can choose which one you like. And now we choose the create planes button to create a plane, and so we can find inside in the center of the window there is the tiny plane, and then we double click it, and then we can change the geometry of it. And the plane we want to change it to the XZ direction, so we choose XZ, and this is the 0.006, and this is the 0.075, and the y is the 0.0125, and this is the 0.05, and this is the 0.331, and then we can update. So now we can find the plane over here. Then we can click done. And for the heads, for a headsink, there are several things. So we will use. We can find the plane is very thin because we forgot to set up the thickness. And so in the property, and we choose the conducting thick, and so we can change the thickness 0.025, and for the solid material, just to choose the default, it is okay. And so we can update it, we can find that the plane has some thickness, and we can choose done. And then we also use the copy and paste. The copy and paste is very efficient, and it's a very good method for you to build your model. And so we right click it, and we choose the copy, and then we want 9 more planes, and we choose the translate, and we use the we want the planes copy paste in the y direction, so we can choose the 0.025 meter, and yeah, we can play it. So now we build all the things of the heatsink, and so this model is almost done. And you can but we can find everything is in trash plane. So if you want to show it, and you can choose the model, and the show objects by material, by property, or by type. I choose by type, and then we can choose the object type plane. Then we can find the display. So we can find this is the things of the heatsink. Yep. Then we close it. So until now we have built all the mechanical parts of this model. So in the second part, we will generate a mesh for this mechanical model. So how to generate the mesh, and we can click the cubic and that is mean the generated mesh, and in the mesh control panel, and we can change the maximum element size, the minimal gap, and change the different parameters. And for now, we choose the minimal gap is in the 1 millimeter and 1 millimeter, 1 millimeter. And also for this is we can change the material, the unit, yeah. So we change 1 millimeter, 1 millimeter, 1 millimeter, and for the maximum element size is 3.5, is 12.5, is 17.5, and now we choose the course. And then we can click the generate. So now we are generate the mesh for this model. About how to set up the parameter for the maximum element size or minimal cap is not there is not an easy answer or simple answer for it. It is based on your question and based on your mechanical, so it's a little bit complicated. So we don't discuss it here, and we can discuss after you have some basic knowledge for the Ansys Icepak. So now we can find the meshing is done. So we can go to the display tab. We can display the mesh and to check it's good or large, and we can click it. We can choose the display mesh, and we choose the cut plane, and then we change the different direction. Okay. So over here, we change the X plane and through filter, and we can move this bar and change the different predictions of the mesh. We go this one. We can find that when we change this bar, and this is show the location of the different card. Yeah. We can zoom in, and we can find the inside of the each thing of the heatsink. There is almost no mesh inside of the things, so it's not good. It means inside, based on if your solution or if your question want to know the temperature of the things, and that is not a good mesh. So we have to change the mesh again, and we want to change the normal one, and we generate it again. And we also go to the display and display the mesh. So for this mesh, we can find that inside the things there are several meshes. So which means this is good. So now we can deselect it and close it. Okay, until now we have finished the first stage to build up the mechanical model, and in the second stage we have generated the mesh. So in the next day we will do some calculation, or we will use the computer to make the solution of this model. And for now we so before the calculation, we have to do some setup. And in the model manager, there are model problem setup and the solution settings. these two settings are for the solution calculation. That is the first stage of the solution calculation. So first we choose the solution settings, and we can double click the basic settings. And in the basic setting, this is the requirements for you. For example, how many iterations equation you want, and also the convergency criteria. You can select a very accurate convergency criteria, but it means you have to use the more computational resources, and in some cases maybe you cannot achieve the convergency. So for this, we just choose we ask the 200 iterations. It means the maximum iteration calculation is 200. If you can't understand this part, don't worry, and just skip this part, and you just input 200. It is okay. You don't need to understand this part for the first time. Okay. After the solution settings, and we go to the problem setup, and we can right click, and we can go to the problem setup weather. So we go into the problem setup weather, and in this model we want to solve for the velocity and pressure, because we have fast. We want to know the air pressure and the velocity inside the cabinet, and we also want to solve the temperature distribution. And then we click the next, and select the flow conditions, and we choose the flow has inlet and outlet the force convention. Yeah, it's based on all of these settings based on your solutions. So there is not only answer. So there is not only answer, and you can change in different problem based on different requirements. And then we can click the next, determine flow region, and set the flow region to the laminar and all the turbulent. This is laminar and the turbulent is two different flow, and I will show the picture over here, and you can find then in the laminar it means the flow direction is almost parallel, but for the turbulent and the different and in the direction of the different flow, and they have some cross. And so in this problem we choose the region of the to the turbulent, and we click the next. And for the turbulent model, and we choose the zero equation, and determine the radiation heat transfer, and we ignore the heat transfer due to radiation. And this one we deselect it, and for the next. And for now we just solve the steady state, so we choose the steady state. And altitude effects, we don't consider it, we just choose next. So we can find at the step 14 or 14 we have finished all the setups, and so we can click done. Okay, after we set up the parameters and the solutions settings for the solutions, and we can click the calculator to ask our computer to calculate it. So we can click run and start solutions. It's a little bit slow. It depends on your computers. For some computer, it could be very fast, and for some computers, it's a little bit slow. And now we can find there the solution residue for the fin 100. And when the trains of the curve is go down, it means your solution is convergency. But if the curve is up and bigger and bigger, and it means your solution is not convergency. You have to change your parameters or the problem settings. But don't worry, and for the beginner, you don't need to understand it in the first time. And if your computer get a different curve, and you don't worry because this is not the results we wanted, and this is will be changed a little bit in different computers. And now I think is okay. We can find that the solution is done, so we can click done, and then okay. And so this is our model. So in the first stage, we build up the mechanical model. In the second stage, we generate a mesh, and in the third stage, we do some setting and do some calculation for the solution. And after the solution, we have to use in the fourth step, and it is to do some examine the results or the show the results. So for the show results, first we can choose the plain card. It means we card our model, and we can take a look at the inside of the different location, and then we go to the plain card, and we can choose the show vectors, and then we change the parameters for the vectors, and we choose the velocity magnitude, and we want the arrow type is dart, and for the calculated is the global limits, so we click update. We can change in different direction. We change to the plane X. So now we can find this is the velocity of the air inside the cabinet. We can find around the fans, the velocity is very fast, but and the speed is slow down, and slow down. And we also can choose the animate and to say it in different location. Okay, so this is the plain card. It means you card different. We click done. And for except the velocity, we also can show the temperature for the plain card. For temperature, we use show contour, and the parameters the plain card contours, and we change the temperature, and yeah, for these calculated the color levels, we choose this object, and we click the update, and done. And we change to explain. So now we can find in this side there are 3 fans, and we can find the temperature is a little bit low, and but when with the velocity of the area is slowed down, and we can find the temperature is increased a little bit. We also can choose the animator to say the temperature distribution or different location. Yep, this is plain card. And we also can display the velocity vectors and the superimposed with the pressure controller. So we can click the plain card again. In the name field, we can choose the card, the pre-velocity, and in the set prediction, we can choose the x-plane, and we can choose the shoe contours, and in the parameters, and we choose the level, spacing, effects, and the color level is this object. We can click the done. And for the vector, this object. Yeah, it's done. Let's choose the global limit. It's done. We can find that we have the 3 post processing, and we don't want to see the first 2, so we inactive and deselect it. And then now we can see we can observe the velocity and the temperature together, and so it's almost, so this is almost everyone, and we deactivate it. Except the cut plane for the post processing, we also can see the surface temperature distribution or some parameters and across the surface. So except the cut plane card, we also can choose the object face. So now we click the object face, and we have to choose the object, and we can choose our sources. We can choose the 4 sources and click the accept, and we can show over here. We show the contours, and we click the parameter and the object face contours, and then we want to show the temperature, and for the shading operation, and we choose the banded. Yeah, for the color level, and we choose this object, and we click update, and we can find done. Yes, so we can find the temperature distribution on the sources. Except the surface, we also can display the line contours of the temperature on the backing plane. So we can click done, and we inactivate. We click the new face for this one, and we can select our backplane of block 1, and click accept, and then we show the contours, and we click the parameters, and we want to show the temperature, and for the contour options, and we choose the solid fill, and we don't want the solid fill, we choose the 9, and for the level spacing, and we choose the fix, and we want the number is 200. And for the color level, we choose the calculated based on this object, and we click the apply. So now we can see the we click done. So now we can see the temperature distribution in the surface of the backplane. Around the sources, the temperature is very high. It's almost 60 degrees, but the temperature, and when the distance is larger, and the temperature is lower and lower. Okay, and that is almost everything for the first example. And in the first example, and we are introducing how to build the blocks, and how to use the sources and the plane, and build the fence. The most important method for you is the copy and paste. You don't need to build everything by use the blocks, and that could be very slow. And after the mechanical block, and I teach you how to do the mesh and generate the meshing. And after you generate the mesh, you have to show the mesh inside of inside your model, and to check what you want to observe. There are some mesh inside the object, If the mesh is not good enough, then you have to make a better mesh. But there is a trade-off. The very small mesh could be require a very long computation time. And after mesh, the third one is how to do the solution. Before the solution, we have to do the solution settings and the problem setups, and then we click the calculation to do some solutions. After solutions and how to show your results, and we have used the plane card. It means we cut our model to say the different location, and we can see the inside of the model. And we also can choose the object face, and we can show the surface of the object what you want to observe. So that is everything, and thank you.